Hurricanes, tornadoes, and severe windstorms can destroy homes, businesses, and lives. But a one-of-a-kind lab is working to change all that.
We visited the Insurance Institute for Business and Home Safety to show you how their amazing tests are determining how structures can better survive storms.
When a storm ripped through this Alabama town, the Claysville snack bar took a direct hit. Walls collapsed, windows broke, the building and everything inside was a total loss. The National Weather Service says the diner was damaged by microburst, a downdraft of sinking air that occurs during a thunderstorm. Sometimes a microburst can produce worse damage than a tornado. This giant concrete building is where scientists with Insurance Institute for Building and Home Safety are looking for ways to make residential and commercial buildings withstand natural and man-made disasters. Today, they're studying the impact of high winds.
No matter where you live in this country, wind is a problem.
Scientific sensors and cameras will capture all sorts of data that will be passed on to the insurance industry, the public, and policymakers to improve the way buildings in the U.S. and the world are reinforced and constructed. They're testing 2 strip mall-type buildings that could easily pass for a diner in any town USA.
Because what we're trying to do is really spotlight a vast and stark difference between doing things the right way and doing things the regular way.
The yellow diner was built with common construction practices used in virtually every part of the country. The green diner was built using stronger, safer construction techniques. More than 100 fans like this will be turned on to create hurricane-force winds. The test is about to start. The wind gust speed quickly climbs. A 73-mile-per-hour wind gust rips off the roofing of one building like a peeled banana. When the winds increase to 100 miles per hour, the roll-up garage door buckles. Wind blows through the diner, sucking the inventory through an opening in the wall. Windows shatter after 2x4s are shot from a cannon to simulate a tree branch. Look closely. At 110 miles per hour, a crack forms near the roofline. Jagged cracks appear in the masonry when the wind reaches 136 miles per hour, and it causes the entire wall to crumble. With the exception of a shattered window, the stronger building has hardly any damage. So here's what made the difference. Better screws, steel cleats, flashing, and roof cover material were used on the stronger building's roof. The AC unit, representing any equipment that might be on a roof, was properly anchored to the steel frame to prevent it from blowing away. Wind-rated doors that stay in place better than roll-up doors that easily pop out of their tracks kept the wind and flying debris from coming inside. Remember those crumbling walls? The walls in the stronger building had vertical steel rods every 8 feet apart, but the common construction building had only steel reinforcement rods on the corners and both sides of openings, leaving most sections of the building vulnerable to the wind. When it comes to high wind performance, it's really all about the details. Rothman says there are still things you can do to reinforce your building to increase its chances of surviving the next big storm if you have proper information.
Take the time to ask questions about how that building is put together, because how it's put together, how it's tied together, is going to make all the difference in the world if a windstorm comes along and tries to tear it apart.
Jeff Rivenpark, America Now.
Here's some info to help put things in perspective. It costs less than 5% more to build a stronger building as compared to the construction cost of a common practice building. In many areas of the country, 5% is less than the cost of sales tax.